Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at section 2.4, and this is on infinite limits. So let's first give the definition, and then I want to talk a little bit about it, because there is one slightly confusing aspect of infinite limits that I want to clarify here. So the definition, suppose f is defined for all x near a. If f of x grows arbitrarily large for all x sufficiently close to, but not necessarily equal to a, we write, and then it's right over here, the limit as x approaches a of our function f of x is equal to infinity. And vice versa, if it's growing arbitrarily large in a negative value, we're going to write it just like this. It's approaching negative infinity. And here is a couple of charts here, or graphs, excuse me, and this is so if this is your a, your x value, and it is approaching positive infinity from both sides, then what we would do is we would say the limit as x approaches a of f of x is equal to positive infinity, this notation up here. Now remember, in both cases, the limit does not actually exist because infinity is not actually a number. And in order for the limit to exist, it has to be approaching a constant. And a constant is, a specific value, like negative 2.1. So in these cases, even though the limit does not exist, we still write the notation like it does exist. And what it's saying is that as x gets really close to a, our y values are growing arbitrarily large. They're growing without bound in the positive y direction. And vice versa when it's going in the negative direction here. So it's a really important distinction that we need to talk about because some textbooks actually teach it a little bit differently. But I just wanted you to know what that means. Now, some of you might be asking, well, what happens if on one side it's approaching positive infinity and on the other side it's approaching negative infinity? Well, that's a great question. In that case, we say that the limit does not exist. We would write like DNE or make some type of statement of its non-existence. However, and we're going to be looking at this in this section 2, we can still look at the one-sided limits. And the one-sided limits we could still write similar to this and this with just the little plus or minus in the exponent position of the a to show if we're coming from the left side or the right side. So let's go ahead and take a look at that. All right, so on page 85 in the book, we have the definition of the one-sided infinite limit. And suppose f is defined for all x near a, with x being greater than a. That means we're looking from the right side of this. If f of x becomes arbitrarily large for all x sufficiently close to a, with x being greater than a, we write just like the last form, except you see the little plus there. It might be hard to see it here, but we put a little plus in the exponent position of the a. And that means we're coming from the right side. And vice versa, if we're coming from the left side, we put a little minus there. And then we would either put positive infinity or negative infinity here, depending on whether we're growing up without bound or down without bound. So here's kind of some examples here. So for this value a, if we were looking at, and let me write this out. So for example, if we were looking at the limit as x approaches a from the right, and I'm looking at this first graph here of our function f of x, it's defined right there. I would say that that is equal to, so as I'm getting closer and closer to this a value from the right hand side, notice my y values are going higher and higher. So that would be positive infinity. Now, if I were to basically do the same thing using the same graph, but I were to look at the limit as x approaches a from the left, that's a little minus there, so I'm coming from the left-hand side now. of our function f of x, I would say that that does not exist because there's nothing to the left side of a there. So that does not exist, D and E. And the same thing if I were to write this out without anything in the exponent position, that would just mean the limit as x approaches a from both sides. Once again, that would be does not exist as well, because it has to exist from both sides in order for us to write the two-sided limit. All right, so let's take a look at this one. So here, from the right, we're approaching negative infinity. From the left, does not exist. There's nothing over there. This one here, from the left, we're approaching positive infinity, but from the right, nothing. So it does not exist. And then here, from the left-hand side of a, we're approaching negative infinity. Remember, we're talking about our y values. Our y values are approaching negative infinity as our x values get closer and closer to a. So the left-handed limit for this one would be negative infinity, and the right-handed limit for this one would be does not exist. All right, now let's take a look at the vertical asymptote. All right, so the definition for the vertical asymptote is also on page 85, and it says if the limit as x approaches a of our function f of x is equal to positive or negative infinity, then this is from the two-sided limit, and then this is a left one-sided limit, and here's a right-handed right side one-sided limit here. If any of those are plus or minus infinity, then the line x is equal to a is called the vertical asymptote of f. So this is a way that we can use limits to define our vertical asymptotes. So if we take a look here, notice that x equals 1. From the left, we're approaching positive infinity. From the right, we're approaching positive infinity. For x equals 3, from the left, we're approaching negative infinity, and from the right, we're approaching positive infinity. So for all of those cases, we're going to have an asymptote at x equaling the value in which these limits occur, the x value. All right, so let's go ahead and take a look at some examples and try them and see how we're doing. Okay, for the first one, we're going to say the graph of f in the figure. This figure here has vertical asymptotes at x equals 1 and x equals 2. And they want us to analyze the following limits. So this is the limit as x approaches 1 from the left of f of x. This one appears to be the same one. Let me double check on that. It's hard to see. That's actually a plus sign there. It doesn't copy over too well. So this is from the right. This here is a two-sided limit. And then this is 2 from the left. That's a little minus there. This is 2 from the right. That's a little plus there. And then this would be the double-sided limit. So go ahead and pause it now. Try to write out what these would be or answer these limits. And then unpause and we'll go through the solution. All right, so really this is just a visual type problem. We don't have to do any actual math, which is nice for some of these. So I'm just going to write a little equals next to all of them. And if we understand what it's asking us, then we can answer these right away. So 1 from the left, that's from the left side of 1, our y values are approaching positive infinity. From the right side of 1, you can see it's coming up here as we get closer and closer to 1 from the right. We're also approaching positive infinity. Therefore, since our left and right-sided limits are the same, our two-sided limit will also be positive infinity. Now for 2, 2 from the left, as we get closer and closer to 2 from the left-hand side, our y's are approaching positive infinity. From the left-hand side of 2, it looks like it's going down, 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 down. So it's approaching negative infinity. And for the two-sided limit, from both sides, since these are not the same, we say does not exist. Does not exist. All right, let's go ahead and try another problem here. Okay, for this one it says sketch a possible graph of a function f together with vertical asymptotes satisfying all of the following conditions on the interval from 0 to 4, including 0 and 4. And we're given all of these things here. So f of 1 is equal to 0. F of 3 is undefined. The limit as x approaches 3, that's a two-sided limit because there's nothing in the exponent position, of f of x is equal to 1. The limit as x approaches 0 from the, is that right? Let me just double check. Yeah, this little plus symbol, so that's from the right, of f of x is equal to negative infinity. The limit as x approaches 2 is positive infinity. And the limit as x approach is 4 from the left, that's a little minus sign there, of f of x is equal to infinity. So this is a tough one. It's really not that bad though, so go ahead, pause the video. Try to just come up with a visual function that meets all of these characteristics or criteria, okay? Pause now, and then we'll go through the solution. Alright, so I just kind of start by drawing my xy graph here, and we're looking on the interval from 0 to 4. So I'm just going to start, I'll do a 1 here, I'll do a 2 there, a 3 here, and a 4 here. Okay. And now what I like to do is first go ahead and take a look at where I have limits to get my asymptotes. So I have a limit as x approaches 0 from the right. So that means I'm going to have an asymptote there. So let's do the asymptotes in red. We'll do a little bit thicker here. And then so I have a vertical asymptote here. And let's see where else. As x approaches 2 from both sides, that is infinity. So I have a vertical asymptote at 2 as well. And finally, at 4 from the left, we are approaching an infinity. So at 4, we will have a vertical asymptote as well. And at 3 here, we're approaching a value, so we do not have a vertical asymptote there. So here's our 3 vertical asymptotes. Remember, for one-sided limits or two-sided limits, whenever we approach positive or negative infinity, there is a vertical asymptote at x is equal to whatever that a value is. Okay, so I've got vertical asymptote here, here, and here. And remember, we're only looking on the interval from 0 to 4, so I don't have to worry anything to the right of 4 or to the left of 0. Let's go back to here. Okay, so at f of 1, so here's x equals 1. My y value is 0, so I'm going to have a point that goes right through there. At f of 3, it's undefined. Now, since I don't have a vertical asymptote there, now, could I put a vertical asymptote? I could. And then I could, from one side of it, I could go from the left, and one side of it, I could go from the right, if this was the only criteria here. I could make one and still make it undefined if one side was positive infinity and one side was negative infinity, or if one side just used any infinity and the other side didn't use or wasn't approaching anything. But looking at this, we know that the limit as x approaches 3 is actually a value here, so I cannot put a vertical asymptote there because as x approaches 3 from the left and the right, I'm approaching the value of 1. Now, here's what we need to take a look at. Remember, with limits, we just have to be approaching that value. We don't have to be defined there. And in fact, we're not defined there. So what that means is that at x equals 3 and y equals 1, I'm going to have a hole. And I can just do that by an empty circle there. And that means that it is not defined here, but the limit actually does exist. So I'm going to have kind of a curve coming from both sides there. Now let's take a look at how I'm approaching. So this is all the where functions are defined at. The last thing we need to look at is which way we're approaching. So from the right, I'm approaching negative infinity. So I can just show that this is going towards negative infinity. This is from the right of 0. From both sides, we're approaching positive infinity. So this can go up like this. And on this side, it has to go up like this, since this is a two-sided limit. And on the two-sided limit, we're approaching positive infinity. And from 4 on the left-hand side, we're also approaching positive infinity. So this can go up there as well. And this would be probably the most basic function that you could make that fits all of these criteria. Although there's an infinite number of functions that you could write out that would fit these criteria. If we wanted to, this function could go down and then back up here, and then down and back up there. We could do lots of things with it. But with this, I'm just trying to do the most basic function that I can. So I hope this helped. And let's take a look at one more problem. Okay, so here's an actual function with the limit notation here. And this says, what is the limit as t approaches -2 from the right, a little plus means from the right, of this function here, t cubed minus 5t squared plus 6t, all over t to the 4th minus 4t squared. All right, so let's see, first of all, what happens if I put a -2 in there. So the first thing I want to do is I want to put a -2 in there and just kind of see, what happens. So just a moment here. So if I look at f of -2, that's going to be -2 cubed, which is -8. Minus 5 times t squared, so that's going to be minus 20, plus 6 times -2, which is -12, plus -12. All right, and then on the bottom here, we're going to have t raised to the 4th power, which is positive 16. That's -2 raised to the 4th. And then minus 4t squared, so that's going to be 16. All right. Now, when I look at that, I'm going to get some value on the top. It looks like -40. And I'm going to get a 0 on the bottom. A 0 on the bottom. Now, what does this mean? Well, it means that once we plug in the actual a value here, if I get a 0 on the bottom, and on the top I get something that is not equal to 0, like -40, that means I'm going to have a vertical asymptote at this point right here. Now, the thing that I want to see is whether or not this thing is going to be approaching from the right-hand side, positive infinity or negative infinity. So one thing I could do is I could put just a value that's really close to the right and then keep checking those. And I'm going to do that in my calculator because I like to use the calculator. All right, so I want to go to y equals here, and here I want to put that function in there. So remember, if we're dealing with multiple terms on the top and the bottom, you always want to put those in parentheses. So the entire top in parentheses would be, and we're just going to use x because we can use any variable we want, x cubed minus 5x squared plus 6x plus 6x. And that's all going to be divided by x to the 4th, x raised to the 4th, minus 4x squared, x squared. All right. And put that in there. The first thing I want to do is check my answer from before, because I kind of did that mainly in my head there, which scares me a little bit. So to check -2, I can just do vars, y variables, function, y1, and we're going to evaluate that at -2. And we get an error because we're trying to divide it by 0, so I at least know that this might be right. Let me go ahead but let's go ahead and see from the right-hand side, because we're going from the right, that's what the little plus exponent here means. We're going from the right, let's see if we can tell if we're approaching positive infinity or negative infinity. So, think of a number line here. Think of a number line. We have -2 here, and let's say we have 0 here. So remember, we're approaching -2 from the right-hand side. So first I'm going to start with a value around there, and then a value around here, and then a value closer and closer to -2. So in this case, I can go ahead and start with like -1.8. Anything that's close to -2 from the right. So I'm going to do a second window. Got to quit out of here first. Second window, and change this to ask. This is a table setup, so it's going to ask me what my x values are. And I'm going to do second graph, which takes me over here, and we say -1.8. And notice I get 13.3333 here, so that tells me at least at that point I'm above the x-axis. But in order to find out for sure, I need to pick values that are even closer to -2 from the right. So let's do -1.9. And it looks like I'm going up. Looks like I'm going up. Let's do -1.99. Get even closer. And sure enough, my y values have skyrocketed to 250. And let's do one more. Let's do -1.9999. Really close. And look how high I am. So from the right-hand side, this is definitely going towards positive infinity. So I would write this as equal to infinity. Now let's say it asked us from the left-hand side as well. Let's do that one even though it didn't ask. But then I could start with something on the left side. So I could start with like -2.2. Notice it's below the x-axis here. And then -2.1. And -2.01. Getting closer and closer. -2.00001, and it looks like it's going down towards negative infinity without bound. So if we're looking at this from the left-hand side, where a little minus in the exponent position, then we would write negative infinity. And then if we were to write it as two-sided limit, we would say does not exist because they're not approaching the same infinities. And lastly, I want to take a look at this graph here. And this is what it looks like. So here would be -2. -2, and you notice that from the left it's approaching negative infinity, from the right it's approaching positive infinity. Now it looks like we also have an asymptote here at 0. Alright everybody, I hope this helped. If you have any questions, please ask them in the forums or send me an email. And we will see you soon. Thanks.